So if we want to take n elements and put them in an order, we call this a permutation. And the number of permutations of n elements is n factorial. So with permutations, order matters. I want you to think about permutations as in like places. If you are running a race and there's 5 runners, okay, so how many ways can they, cross the finish line? Well, we have 5 slots to fill. We have 5 people that could come in first. Now, once somebody comes in first, there's only 4 runners left in the race. So we only have 4 options for second place, and then only 3, and then 2. And then by the time 4 runners have finished, there's only 1 person left that's going to get last place. Okay, so that's 5 factorial. So we want to know how many permutations of the letters W, X, Y, and Z are possible and list them out. So that's 4 letters. So 4 factorial is 4 times 3 times 2 times 1, which is 24. You have a factorial button on your calculator. If you're doing the scientific one, remember it's in your probability menu. If you have a graphing calculator, go to math and then arrow over to probability and you'll find it. Okay, we're going to list these 24. We're actually going to do this. It's fine. So the first way we can do this is W, X, Y, Z, and then W, X, Z, Y. Then we'll do W, Y, X, Z, and W, Y, Z, X, and then W, Z, X, Y, and W, Z, Y, X. So those are all the possibilities with W first. So now let's put another letter first. We'll put X. So X, W, Y, Z, or we could have X, W, Z, Y. And then we could do X, Y, W, Z, X, Y, Z, W, and then X, Z, W, Y, and X, Z, Y, W. Those are all the possibilities starting with X. So now let's start with Y. Y, W, X, Z, Y, W, Z, X, Y, X, W, Z, Y, X, Z, W, and Y, Z, W, X, Y, Z, X, W. Those are all the possibilities starting with Y. The last letter we need to start with is Z. Z, X, Y, W, Z, X, W, Y, Z, W, X, Y, Z, W, Y, X, and Z, Y, X, W, Z, Y, W, X. There are the 24 of them. All right. A chess club has 5 members, and they want to pick a president and vice president. So now we just have 2 spots we want to fill. So we have 5 people to choose from for that first spot. And now for our vice president, we can't choose the same person twice. They can't be president and vice president. So now we only have 4 people left for that second spot. So there are 20 different ways to choose president and vice president. So this is a little bit different problem. And that brings us to our next definition. The number of permutations of n elements taken r at a time is this NPR. And here's a formula, n factorial or n minus r factorial. Again, order matters. Order matters in this problem because there were president and vice president are 2 different things. But not everybody in the chess club gets an office, okay? We're only picking 2 of them. So if we did this using the formula, this is 5 permutation 2. So that would be 5 factorial over 5 minus 2 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Those are all going to cancel, and we end up with 20, just like we did before. Again, your calculator has this. If you're doing a scientific calculator, you have to put in 5 and then go to your probability menu to find this P and then put in 2. Graphing calculator is the same thing. You just go to math and probability to find it. The Desmos calculator has it too. In another video, I'll show you how to do it on Desmos in case you don't have any other calculator to work with. All right, we have 8 horses running in a race. How many different ways can they come in first, second, and third? Okay, so we can do this 2 different ways. We can think about first, second, and third. So we can say we have 8 options for first place, and then 7, and then 6. Or we can use that formula or our calculator, say we have 8 horses, and we want to know the permutation of 3 of them. Okay, either way, this is going to give us the same answer of 336. Okay, and again, this is a permutation because order matters. All right, 12 students apply for scholarships. 1,000 is awarded to the top student, 600 to the second, and then a little less for third and fourth. How many different ways can the scholarship be awarded? Order matters here because the money amount is different, so this is definitely a permutation. We have 12 students, and we are handing out 4 different scholarships. Okay, so you can just put that into your calculator. It's 11,880 ways. All right, now, suppose we wanted to find the possible permutations of the letters A, B, and C. So there are 4 factorial permutations, okay, because we have 4 elements here, just like the W, X, Y, and Z. But since we have 2 identical A's, not all the permutations are distinguishable. So that means we can't tell the difference. So when that happens, we have to count the number of distinguishable permutations. So if you have n objects, n1 of one kind, n2 of a second, n3 of a third kind, and so on, the number of distinguishable permutations is still the n factorial, but then we divide it by each of the breakdowns. Okay, and we do this when we have elements that are identical. So, for example, how many distinguishable ways can the letters in the word banana be written? All right. So we have 6 letters here. So we're going to do 6 factorial. That's our numerator. And then we have 1b, so that's 1 factorial. And then a's, 1, 2, 3 a's, so 3 factorial. And then 2 n's, 2 factorial. Okay. So when we do this, 6 factorial is 720. When we multiply everything on the bottom, we get 12. So there are only 60 ways that the letters in the word banana can be written. 6 different ways that are distinguishable, because if you switch around the A's, they might still be the same. All right, we have a store. It has identical scarves, red, blue, and green. How many distinguishable ways can they be arranged on the rack? Let's see, we have a total of 9 scarves, so 9 factorial on top. We have 4 red, 2 blue, and 3 green. So definitely want your calculator for this one. 9 factorial is a big number. And then multiplying everything on the bottom, we get 288. So there are 1,260 ways to arrange those scarves.